Hi and welcome to Houdini tutorial 2. Here I was planning to move ahead with our dynamics network, but and since the monsoon is almost there in most of the cities, decided to make an exercise where we can produce our raindrop ripple effects using our Maya dynamics nodes. I have got the finished file here in the beginning for you to see, just to understand what this will be, and you can take a look. You can take a look. See, we've got this ripple effects on this plane here, something similar to our normal rain ripples. Now, to understand this kind of a exercise, I would like to just show you the network on which we are working with. This is my network. I'll just press L to zoom it in. Okay. Now we'll be adding individually these nodes and seeing how we've gone about doing this, bringing out this network. Okay, so let's take a new scene here, and I'll discard this because I've already saved whatever I wanted, and let's check this. All right, let's take a new scene, and we'll add a grid object first. Now, a grid object is something similar to what you would call a plane object, your normal plane or planar object which you get in your other 3D applications. This is your grid object. I'm going to just close down this pane because this somehow disturbs me while working. So I'll keep this open, and for my network view, I'm going to just open up a new panel. Shortcut for this is Alt Shift and W. And I've got my grid here, and let's just press L to bring in my grid object onto the scene. Double click and go inside, and first and foremost, since we are working with a lot of polygons here, we'll be working with ripples, so obviously I'm going to need to increase my number of polygons. So I have got rows as 10 and columns as 10, so I'm going to shoot this up to somewhere around 80 by 80. If you've got a machine which is supporting further, please go ahead, because higher the number of rows and columns, as we know, it will give us a better deformation on the plane. So I have added my rows and columns here. Let me come back to my grid view here. Okay, first and foremost, what I'm going to do is I'm going to add a null object. Null object is something like a group. I'm going to connect this grid to my null object here. So I connect it here, and I'll just rename this null object as my initial. See, basically our ripple object is going to work when we have a difference between two different meshes. Okay, we have to produce an initial mesh and a final mesh. Initial mesh is, as you can see, a planar object which doesn't have any deformation. We need to add a minimum deformation to the scene now, so that I can make it my final mesh. Now, to do that, first and foremost, I need to add a pop network. So let's add a pop network. Pop network is nothing but your particle network which is coming onto the scene. I'm going to double click inside, and you can just connect this initial to the first element here. I'm going to double click inside, it's empty. We need to add something called as my source. So this is to tell my pop network or my particle object where the mesh is going to come out from. And even before that, I need the rain to fall, right? So if rain is going to fall, it's obviously going to fall from a height. So I can always take a different object here and set that as my particle emission geometry. Or one of the most beautiful things about our Maya nodes is I'm going to just delete this connection here. I'm going to disconnect this, and I'm going to add something called as transform. So what does this transform does? I'm going to connect my grid object to my transform. Okay, and in my transform, I'm going to translate this on Y, so somewhere to 5. So what happens is, this is a transformation of that same plane here. The advantage of using a procedural network is I can connect this transform plane separately to my pop network. See. So now what happens is, instead of taking a duplicate geometry here, I've got the same geometry which is going to emit the particles. Now you just go into popnet, and I have added the source here. So obviously the source is not connected to any object here. You can see geometry source is set to use parameter values. I'm going to use first context geometry. What is my first context geometry? My first context geometry is the transform. This is the first context geometry here. My transform is connected here. Alright, so this is my basic particle network. I'm going to go into source and just go to birth here. My constant birth rate is set to 100. I don't need 100. I'm going to take 40 particles because I want to show you the effect, because maybe 100 particles is a bit too much. So see what happens here. It's emitting the particles like this. Now why is it emitting it like this? If you come to source, you can see here emission type is set to points ordered. Let us change this from points ordered to surface random. Right? When I set it to surface random, what happens? It is going to emit randomly on my scene. Now at the same time, I need to bring down these particles. These particles need to fall down. So I'm going to add a gravity. So just come back to my grid object, select my pop net and come to drive particles. Here you've got gravity. Okay, so what does this do? Let's go back in. I don't think my gravity has worked here. I'll just come back and select the source here and let's hit gravity. Okay, so my source automatically gets connected to gravity here, and I'm going to just rewind this and I'm going to play. I can see my particles falling downwards. So this is my initial setup wherein these particles will be acting like raindrops and they are going to fall down. Now obviously when they are falling down, they need to collide, right? They need to collide with what? With my grid object here. This is my grid object. They need to collide with this grid object here. So what I'm going to do is I'm going to add up a collision to my pop net. Let's come here and add collision to my pop net here and connect my gravity to the collision, and I will focus in onto the collision here. Now what is it going to collide with? Let's pick up my initial init group. Okay, so you pick up the initial null object from here and click on accept. Okay, so automatically if you look at behavior, the behavior is set to die on collision. So with that default behavior set, I'm just going to play here and you can see it's colliding as well as the particles are dying on the collision. They are not moving down any longer. So this done, once I've done this, now I need to next go to the next level where I'm able to add deformation onto this plane. So to do the deformation, we need to give some volume to my particles. Now if you see the particles here, they are just points, so they are not going to go and give a lot of deformation here. So what I will do is I need to add a metaball object. So I need to add a metaball object here, and I'll just do that. Metaball. I've gotten a metaball object here. Now each and every one of the particles which were falling down have to be populated by these metaballs. So I'm going to take a copy node here. So what does this copy node does? I'm going to connect my metaball to my copy 1 and I'm going to connect my pop net over here. So it is going to copy these metaball attributes onto all my particles. So I'm just going to rewind here and take a look at what is happening. You can see they are forming into metaballs and they are falling down. So let's just look into my metaball attributes, because I need to change a few settings there. We'll come to metaball attributes. The radius is set to 111. Now I'm going to bring down my x, bring down my y, at the same time bring down my z also. Okay, so it's at 0.1, 0.1 and 0.1, and let's just see. Okay, sorry, we need to focus onto the copy. Let's rewind this plane now. You can see my metaballs are falling onto the scene. Okay, now obviously these metaballs need to interact with my grid object, which is the plane. Okay, I'll just show all objects on here. Okay, so how do we do that? We add a bulge node here, and I'm going to connect this copy, these metaballs which are being part populated here to my bulb's output here, bulb's second input here, and I'm going to take this initial null object and connect it to my bulb. So what happens after this? After this, let's play now, and we can see that these metaballs are coming down, but I'm not able to find much of a difference onto my mesh object here. Let me just pause this and zoom in and see. You see, my mesh is not interacting much. The reason behind that is my bulb's magnitude is right now set to 0, so I'm going to bring it up to 0.1. Okay, so as soon as I hit 0.1, you can see there's a small change in the mesh here. There's a small deformation in the mesh here. But the problem that we are facing is this deformation is quite low. See, my metaball size is set to 0.1, 0.1, 0.1. Now the x and y can be 0.1, but I need to give it some depth here, right? So let's just bring this depth up, so to somewhere around 0.8 or something. Okay, and now you can see my metaballs have elongated, so that 0.6 would be fair enough size. It is so that it gives a certain depth to my bulbs. Now if I come back to my bulbs and if I just make it visible here, let's see, you can see this now, that there's this bulge here which is coming. Let me just rewind this and let's play to see how the updated network is interacting now. Okay, you can see those bulges are coming, bulges working fine, because you can see these interactions coming up here and here. Okay, let's just zoom in so that you can see it more clearly now. Okay, you can see this bulge here, it's clear. So once we've got this, what we'll do is, this is going to be my final state. Okay, I have got my initial state here. I'm going to add a null object here and connect this here and set it to final. Okay, so I've got this initial here and I've got this final here. So this is how my network is going to look like. Let's come back to my object level, and since I need to add a ripple here, to add a ripple solver and a ripple object, you need to add a DOP network first. So I'm going to add DOP network. A DOP network got added. Inside this, I'm going to add a ripple object and I'm going to add a ripple solver. I'm going to connect my ripple object to my solver and click on my ripple object. See, it's got this initial SOP path and the rest SOP path. So I'm going to take initial SOP path as my initial and my rest SOP path as my final. And I'm going to switch on a deforming rest because my rest object is going to be deforming continuously. With that set, let's rewind and play. Are we getting anything? No, we are not. Let's just see what has gone wrong. Come back to my object level. I'm going to go into my grid object. Alright, switch on your final, focus on the final, and see now. Rewind and play. No, I am still not getting my ripples. Let us go back into the network. Sorry, focus onto the ripple solver. There's quite some calculation going on, but we are not getting the display. I'll just pause the video for a second and take a look at what has gone wrong in the network and come back. Okay, let's continue. I'm going to play this here and we're going to give it some time because the particles need to travel down. Yes, you can see this, these ripples are forming slowly, very low, low deformation here. You can see this slight changes, What we are going to do now is we are going to simply shoot up onto the ripple values. Just go into your DOP network and take the ripple object. Sorry, take the ripple solver. You've got this wave speed here. I'm going to bring this up to 5. Okay, and let's rewind now and let's play. Just wait for the particles to flow down right up to the geometry. Yes, now you can see the ripples have come up. Now obviously I have used a low res plane where the grid where there are only 80 by 80 divisions. If you had gone for a higher divisions like 100 by 100 divisions, you would have got a much smoother playback. I'm going to just save this file one, and just for understanding, let me just go back to my object level, go to grid, and just to understand, I'm going to shoot this up from 100 to maybe 120 by 120 to see how much the particle is going to work. Now I'll just come back to my object level here, and let's rewind and let's play. Stop this. I'm going to stop the video and move ahead. Okay, it's simulated for quite some time. You can see here these ripples getting generated, and because of a very high wave speed, these ripples are moving about. So that was about how to make ripples using our Houdini dynamics network. That will be all on this lesson. I would appreciate a feedback on the tutorial in the form that has been mailed to you. Thank you very much.